Okay, so we have a plate of concrete. It's a uniform, a concrete slab that has a mass of 2,400 kilograms. Okay, and the question is, what is TA, TB, and TC? And we also have a load that is applied at this point of 15 kilonewton. So let me add for that we know it's uniform, so it means that G is in the middle. So we have G, that's the point G, okay, and we can draw the weight in the middle. The weight, it's equal to 2,400 times 9.81. That's 2,400 times 9.81, 23,544 Newton. Okay, and we have a load there of 15 kilonewton. Let's call that P is equal to 15,000 Newton. I just use the same unit. And we have three unknown forces. We have TA, TB, and TC. Okay. So this is a 3D problem, a 3D equilibrium of a body. So potentially we have three equations for the forces: force on X, force on Y, and force on Z, and three moments about the three axes. So the moment about X, the moment about Y, and the moment about Z. Okay, we will try to be strategic with the equation that we use to solve one and one at a time. Okay, so first, force on X, force on Y, we don't have any force on X, force on Y. If we write the equation for force on Z, we have three unknown. So that will not help us to solve any equation yet. If we look at TB and TA, you see those two unknowns, they are aligned with the axis X. That means that when we do the moment about X, they are not included inside this equation. So if we use the moment about X, we are able to solve for T, what's the one in front? TC, the one that's going to this point. So let's do first the sum of the moment about X equals 0. Okay. So what do I have on X? So we have the 15 kilonewton, this one, that tend to rotate in the negative direction about the axis X. Okay, let's try to rotate in these directions. So minus, and the perpendicular distance is 0.5. Okay. We have the weight that tend to rotate in the negative direction, so minus the weight that 23,544. Okay, so that was the load, that was the weight, and the distance it's in the middle of the plate, and the plate is 2.5. So this is 2.5, 1.25. So times 1.25. Okay, and we have to balance. We only have TC that tend to rotate in the positive direction, so plus TC time this perpendicular distance between the axis X and the point C. That's 2.5 equals 0. Sorry, my organization is not perfect. But thanks to that, we can find the value of everything there on the left. Let me do that in my calculator. So we have 15,000 times 0.5 plus the 23,544 times 1.25. So this is 36,930. And this is equal to TC times 2.5. Okay, I put TC times 2.5 on the other side is minus, and all my minus, I can remove them and have them plus. So we got TC that is equal to 36,930 divided by 2.5. 14,772 Newton, that we can write 14.8 kilonewton to keep on this three significative number. Okay, so we use the moment about x. Okay, for the force on z, we still have two unknowns left, ta and tb. So we have moment about y and moment about z. Moment about z, we will not have any equation for moment about z because all our forces are parallel to the axis z, so they don't create any moment about z. But when we do the moment about y, let me clean this a little bit. So that's this one, moment about y, okay, in this direction or these directions, we have two unknown, tb and tc, but tc now, it's a force that we know, it's a blue force. So we will be able to solve for tb. So the second equation that we will use is sum of the moment about the axis y equals 0. Okay, so we look at the y, we have w in the positive direction, so plus the w time this distance there, that is 2. We have the 15 kilonewton, so plus the 15 kilonewton times the total distance up to z, that is 3. TB, no, that's TC. I was this TB go there. Okay, this one is C. So TC, that's negative TC because TC tends to rotate in the negative direction about the axis Y time the total distance between C to the axis Y. So that's 4. And TB is also minus TB time. This TB is aligned with G, is time 2. It's equal to 0. So on the left, we have W, that's 23,544 times 2 plus 15,000 times 3. TC, we found 14,772 times 4. And this is equal to TB times 2. So everything on the left is, let's reuse my numbers in my calculator. This one times 2 plus 15,000 times 3 minus the 14 times 4. This one on the left is 33,000. And this is equal to TB times 2. So we have TB that is equal to 33,000 divided by 2. That is 16,500. So that's Newton. That gives us 16.5 kilonewton. Second answer. And now we use a moment about y. So we have one equation left. That's sum of the moment on z is equal to 0. And now TB, it's a known force, blue force. So we will be able to solve for TA. That is our last red force, unknown force. So we have our equation on z. We have TA plus TB plus TC minus the weight and minus the load 15 kilonewton equals 0. So we have TA plus TB at the 16,500, TC at the 14,772 minus the weight 23,544 and minus the 15. It's equal to 0. So when you switch everything on the other side, don't forget to switch your sign. So we have the 23,544 plus 15,000 minus 16,500 and minus 14,772. TA equals 7,272 Newton. Oops. And that gives us TA equals 7.3 kilonewton. And that's it. Let me highlight the 3 answers: TC, TB, and TA. And what if you found something negative? It's not possible. There's a mistake somewhere because it's just tensions, because it's cables and they can only pull, they cannot push. And you see with the right strategy, so what we did moment about X first, moment about Y second, and the force on Z on the third. It's not always possible, but there it was possible, and we avoid to have a system of a matrix with 6 equations, 6 unknown, or 3 and 3. That's easier that way. So that's it for this video. Bye bye.